Okay, so looking at our functions stuff. Oh, oops, in highlighter. Okay, looking at our function stuff. This question says, a function is defined as, and it gives me what the function is defined as. Okay, that's a piece of information there that I might use later. Okay, x is a real number. Write down two factors of f of x. Okay, if you're finding factors, what are you doing? Factors, you factorize. Okay, so what they're asking me to do here is factorize. Okay, sorry, I'm in highlighter again. So I have f of x is, my original equation is 2x squared minus x minus 6. Okay, I need to factorize this quadratic. Now, my leading coefficient is not 1, which means I need to multiply that leading coefficient, the number in front of the x squared, I need to multiply that by my constant at the end. Okay, so I'm not looking for factor pairs of just the number at the end. I'm looking for factor pairs of 2 times that number, so times the minus 6. Okay, so I'm looking for factor pairs of minus 12. Okay, and when I list all them out, I'm going to ask myself, okay, which of those add to give me the number in front of the x, so minus 1. Okay, so list out your factor pairs for minus 12. So because they're multiplying to give me a minus, it means the signs have to be different. Okay, and if I was to think of something like 3 and 4, and I'm deciding which one of those signs will I make a minus, or which one of those numbers will I have as a minus, okay, because they're adding to give me a minus number, I know that it's the bigger number that's going to have to be a negative. Okay, so 3 and 4 here is going to work for me, a 3 and a minus 4, so that they add to the minus 1. Okay, now this isn't as simple as just opening up two brackets straight away, because we have a number in front of the x squared. Okay, so instead of just jumping to opening up brackets, what I'm going to do is I'm going to rewrite it out, and this minus 1x I'm going to rewrite as minus 4x plus 3x. Okay, and then I have my minus 6 at the end that I'm going to carry down. So I'm rewriting this as two things that add to give me that anyway. Okay, so I'm just rewriting it out here, so that basically what I'm doing is I'm setting myself up to be able to factorize this using my grouping 4 terms method. Okay, so I can factorize this equation that I've just now given, or expression that I've just now come up with, by looking at my first 2 terms together and doing highest common factor method, and then my last 2 terms together and doing the highest common factor method. Okay, so if I take the first 2 terms here and take out their highest common factor, I'll be taking out a 2x, and then I'm asking myself, what do I have to multiply by to get back up here? So I'll multiply by an x and a minus 2. Okay, and then over here, likewise, I need to take out my highest common factor. Now we said the sign from the middle is usually the sign that gets carried down. Okay, so a plus in this case. And then my highest common factor from them two is a 3. Okay, and then I'll be left with an x and a minus 2. Okay, at this point, we should see that inside our 2 brackets is the same. Okay, that's brilliant. That's what we're expecting to happen. Okay, now if, for example, I didn't spot here that I could take out a 2 and I only took out an x, okay, what we'd see in here is a 2x and a minus 4, and we'd see, oh, look, those brackets aren't the same. I must have missed something here, okay, or here. But over here, I would spot, if I had, let's say I had taken that as x by 2x minus 4, okay, when you do something like this, okay, you need to check, is inside the brackets there, do they have nothing left in common? Okay, they still have something left in common. They still have a 2 that can be factorized out. So technically I have an x times a 2 times an x minus 2 if I factorized out the 2 from in here. Okay, and that's where I'm ending up with my 2x and my x minus 2. So it is important that inside those brackets end up being the same. Okay, if in here was the same terms but with different signs as to what was in here, it means that you have to switch the sign of what was outside there. Okay, now that I have gotten the same things in the brackets, what I'm going to do is I'm going to open up my two brackets and I'm going to write, well, what were the terms from the outside of the brackets? I'm going to put them in a bracket together. And then the common bracket I'm putting in here. Okay, now we went through these factorizing questions a lot, and there is other videos on them as well, and there's loads of notes and stuff on them. Okay, so if that's something there that is something you're finding difficult, okay, that means that you need to go over your factorizing. Okay, factorizing quadratics or quadratic trinomials. Okay, now it says hence or otherwise solve for f of x equal to 0. Okay, so it's saying hence. First thing is hence. What does hence mean? Okay, it's using what I got in the last question. Okay, so using my answer from above, using, I'll say, part A. Okay, so it's just the last part that you used, or otherwise. You don't have to use your part A answer. Okay, you can do it another way, but it wants us to solve for f of x is equal to 0. Okay, so f of x equal to 0. So straight away here, I'm going to write down, well, what is f of x being equal to 0? So f of x was 2x squared minus x minus 6. Okay, and they're saying that that is equal to 0 now. Okay, so a few different ways that we can solve this. Okay, if we look at what we have in the equation above, we actually have already factorized this. Okay, remember how we can solve a quadratic trinomial? We have two ways. We can use the minus b formula, or we can factorize it and solve that way. Okay, and in the last part, we actually have it factorized. So that's why it's saying hence. Okay, you can use what you found it was factorized in the last question. Okay, so you can use that to speed up getting your answer if you know how to use it, which we do. Okay, that's just the factorized version of this. Okay, we found that in part A. Okay, we could have done it otherwise. We could have used the minus b formula, or we could have refactorized or something like that. Okay, but I'm factorizing it and then I'm solving it that way. So when I factorize to solve, okay, I have it equal to 0. And what I'm looking to do is I'm letting each bracket that's multiplying to get me 0, I'm going to let each of them equal to 0. Okay, so I have 2x plus 3 is equal to 0. And I have x minus 2 is equal to 0. Okay, so here I need to start getting x on the side by itself. I'm going to get rid of the 3 that's adding by subtracting. Okay, so I want to subtract 3 from both sides. And then I want to get rid of the 2 that's multiplying by dividing. Okay, so I'm going to divide by 2. So I have x is minus 3 over 2. Okay, or if you want to write it as minus 1.5, that's fine as well. Okay, in this one, I need to get rid of the 2 that's subtracting. So I'm just going to add 2 to both sides. Okay, so I have two answers there. They might be kind of hard for the examiner to spot. So I'm going to get my highlighter and I'm just going to highlight them. Okay, or draw a box around them. Remember, we don't use red pen. I know I use red pen here to just try and have it easy for you guys to follow. But if you're drawing a box around your answers or something like that, you're not doing it in red pen. Okay, we avoid using red pen completely in the exam. Now, so again, this part here, that's a bit of algebra. Okay, so that's factorizing and this is solving quadratics. This part here now is using what we know from functions. Okay, what we know from functions straight away here, a few different things. First part, in the domain minus 2 is less than or equal to x is less than or equal to 2. Okay, it just means that they want the graph drawn between these x values. Okay, so remember our domain, what are the inputs here? We're going to draw for all the inputs between minus 2 up till 2 on my graph. Okay, x is a real number, so we're going to draw it for all the points, including all the decimals. Okay, now we need to draw this graph. Okay, it doesn't specifically state to do an input-output table, but you need to do one. Okay, so yes, you can type in this into your calculator to get the table out. Okay, but if you do that, remember, if you're typing something into your calculator and getting an answer from your calculator, you do need to still write that answer down. Okay, so you should, at the very, very least, if you're putting this into your calculator, you should have an input output table done out. Okay, so for each input, okay, so for example, -2, -1, 0, 1, 2, okay, what are the corresponding outputs? So that should be written out on your page. Okay, to do that in your calculator, there's different ways of doing it. We do have a video on that at the start of our functions playlist. Okay, so pop that into your calculator there. The other way you can do it without your calculator, okay, is, so again, another input output table. And for all these different x values, so -2 all the way up until 2, because that's what they told me the domain was. We type in, or we sub in here for whatever we say x is. Okay, so we will sub in this equation here with all my different values of x to get the corresponding f of x value. Okay, because the corresponding f of x value is a y value. It's a y coordinate. Okay, so f of x is another way that we can say a y coordinate. Okay, so for example here, if I was subbing it in with -2, I would get 2 by -2 squared minus a -2 minus 6. Okay, so my matching y coordinate there is going to be 4. Okay, so you're either doing it by actually showing the table here, okay, or if you're typing it straight into your calculator, that's fine, but you do need to still write this out. Okay, so we get a value here of 4. Okay, then we're going to get -3, -6, -5, 0. Okay, so when x is -2, so here x is -2 at this point, okay, y is 4, so here at this point. Okay, so there is my first point that I have from these. Okay, have I just made a mistake? Yes, because before I started drawing on my graph, I should have gotten out my pencil. Okay, there, that's not my pencil. There's my pencil. There is my first point. Okay, then at -1, I have 3, I'm at -3, so all the way down here. Okay, 0 is at -6. 1 is -5, so here. And 2 is at 0. Okay, so is this symmetrical around the y-axis? No. Okay, it's not symmetrical around this y-axis, so I'm not expecting that this 6 will be the lowest point. Okay, I'm not expecting a graph that's going to be like this. Okay, I'm not expecting that. Okay, what I'm expecting is, if we think about this, okay, it's probably symmetrical somewhere around there, okay, slightly after the y-axis. Okay, so remember, our quadratics, they are symmetrical, but it's not symmetrical around this y-axis, because then the points would have been back up symmetrical like this. Okay, and they weren't there. So it's not symmetrical around the y-axis. Okay, that's the first thing. So it means that this is not my lowest point. The graph can continue lower. Okay, remember, we're just doing a nice smooth curve. So it might get lower than this -6. Now, if I went and got my ruler and started joining these dots like this, okay, that's straight away incorrect. Okay, this is a quadratic. We only get our ruler out when we are drawing something that is linear. Okay, this is quadratic. We can see that in the power of 2. We can see that in our points. They are clearly, we're not going to try and draw a line like this. Okay, it's not going to go through any of my points. So it's a quadratic, which means it's a freehand curve. Okay, get your pencil out. try a curve. Okay, you can draw it in very, very lightly if you're getting used to drawing these freehand curves. And then once you're confident with it, go over it. Okay, that's what the curve should look like. So see the way here, it actually goes down past the -6 a little bit. Okay, and it's got this axis of symmetry that is actually to the right of the y-axis, somewhere around here. Okay, so when we move on to the next part of this question, it says use your graph to show that your answers from part B are correct. Okay, now in part B, we found what when f of x was equal to 0. What is it when f of x is equal to 0? What have we found? Okay, so I even said this here. I said when we were doing this input-output table over here, what is f of x also known as? It's also known as y. Okay, so we have in our table here clearly a value of y being 0 when x is 2. So that was one of our answers from part B. We said when x is 2, we get a y value of 0. But we also have one here, minus 1.5 for x is going to give me y is 0. Okay, so it says use your graph to show your answers from part B are correct. Okay, so we need to do this out clearly. Okay, so f of x being 0 means that y is equal to 0. Okay, so if it asks us when f of x is 0, okay, what that's saying is when is y equals 0? What's another word for y equals 0? Okay, they also can be called our roots. Okay, so in part B, we found our roots were minus 1.5 and 2. Okay, so I'm going to write this out, were found in part B as x equals minus 1.5 and x equals 2. Okay. I'll say these values of x on the graph are roots, okay, or are intercepts with the x-axis. Okay, so here, so I'm going back to this graph with a different color, okay, and I'm marking these in. These questions, guys, are an opportunity for the examiner to say, ooh, have you covered all bases? Okay, bases. So we want to make sure that we really do. Okay, we want to show the information that we know here. So we've shown that we know its roots. They were found in B as minus 1.5 and 2. Okay, so I'm going to say this corresponds with the graph with the x-intercept, okay, so where it crosses the x-axis in my graph. And I'll say, as seen in C. Okay, it's very difficult here to make sure that we have covered exactly what they're looking at, okay, what they're looking for. So make sure here that your answer is giving as much information as you possibly can. Okay, so those are my x-intercepts. Okay, and the next question says, on your graph, show the axis of symmetry of this function and write down an equation for it. Okay, so 2 out of 5 marks for being able to show the axis of symmetry. Okay, so again, I am drawing a sketch of some sort. So I am going to use my pencil. Okay, and I'm going to draw in where I feel the axis of symmetry for the graph that I've drawn is. Okay, Remember how we write the equations for drawing that axis of symmetry. I should say you were getting 2 out of 5 marks. Okay, so even if you're not sure how to write this equation that I'm about to talk about, okay, drawing the axis, you're getting 2 out of 5 marks. Now, for drawing a vertical line on a graph, okay, let's say I even just had a vertical line here. Now that's a very thin line. Let's see, back to my pen here. Okay, so drawing in a vertical line here on the graph. Okay, what is that line? So we looked at vertical and horizontal lines and writing their equations. Okay, in this case, for my green line, okay, what is x when y is minus 2? X is equal to minus 3. Sorry, is equal to 3. Okay, down here. When x is minus 1, x is equal to 3. When y is 0, x is 3. Okay, so it doesn't matter what my y value is. Okay, when I have a vertical line here, what it's saying is the value for x does not change no matter what y is. Okay, so x does not depend on y. So when I write this as an equation here, okay, it is literally going to be, well, what is x? Because it's a vertical line, okay, it's going to be x is equal to whatever it's equal to, okay, no matter what y is. Okay, so no matter my value for y, we always have this same value for x the whole way up. Okay, and what is that value of x? Well, let's look and see, well, where did it cross over? Okay, I'm going to say it's about, oops, sorry, I thought I was in my pen. Okay, I'm going to say that that's at about 1/4. Okay, so I'm going to say that x is 1/4, no matter what my y coordinate is in that vertical line. Okay, the only reason why I done a dash there is because it asks for an axis of symmetry. Really, could have just done a full line. Probably should have. Okay, because why not? Okay, so one full line there. Okay, that's that question done. So my axis of symmetry there is x is 1/4. It's dependent on your graph. So you need to have that axis of symmetry marked in on your graph in order for you to have gotten the equation. Okay, if you drew this graph wrong, but you marked in an axis of symmetry and wrote down the equation, then you're getting the marks at least for this part, even if you didn't get the marks up here.